We're starting the distance formula and midpoint. Feel embarrassed. I teach algebra and I can't remember to go over distance formula, but you should all know what a midpoint is. If you're in Algebra 1 last year. Distance formula, I can't remember if you do it or not. I don't think we do we?
We do what?
The distance formula in Algebra 1?
I don't think so. This is real.
That's why I don't remember it. But the midpoint, we definitely know the midpoint. But we're going to start off with a real easy few examples. It says use the number line to find each distance. Did you guys notice, remember yesterday I said if you want to know the distance of a segment, you don't put that bar on top? Did you guys notice how it just says DE and not DE with a bar? So that means it wants its length. But let's count how far away D is from E. What do you guys think? 4. 1, 2, 3, 4. What about AD? 5. BE? 8. We all agree with that? I agree. But that was pretty straightforward. You just one-dimensional. You can just count on a number line. Well, we're going to get into two-dimensional, which is why we have a distance formula. But first, I'll show you how you can do it using a way you already know how. The Pythagorean theorem. What is it? Who knows it?
A squared.
Right, that's the Pythagorean theorem. What do you need to know about the Pythagorean theorem to use it?
A, B, and C.
Yeah, what are they? What are A, B, and C? Can I draw a triangle on here to find the distance of GH? Yeah. Right, I can come over like this and up like that. But the biggest piece of information you need to remember is it has to be what kind of a triangle? Right triangle, right? So there's my right triangle I drew in. And then what does C always represent?
The one you're trying to find.
Yes, the longest. Not necessarily the one you're trying to find, but it's always your longest side. And what's always my longest side on a right triangle? Hypotenuse. So that's C. Can I figure out how far it is from G to this point here? Yeah. We can just count, right? How far is it? 2. And what's this guy? 1, 2, 3, 4, 5, 6. So I know you think you can count, I can count 1, 2, 3 all the way to H, but you won't be very accurate, so that's why we can use the Pythagorean theorem. Because now A, let's pretend this is my A, and that's my B. So I'm going to have 2 squared plus 6 squared equals C squared. What's 2 squared? 4. 6 squared. Add them together, we get 40 equals C squared. How do you undo something squared?
Square root.
Square root. Anyone have a calculator? Approximate that for us. 6.32. So if you have a coordinate grid and you want to draw in a right triangle like that and solve for the length of a segment, that's a perfect option for you to do. But sometimes we're going to get points that are like way far away from each other, and drawing a triangle won't be as nice, so that's why we have the distance formula. Did we? Okay. So if you want to jot that down, that is our distance formula in that box. And again, we use this to find the distance between 2 points on a coordinate plane. Just make sure you copy that this is a minus inside the parentheses and then a plus between the two of them. Okay, let's try an example. So we need to find the distance between C and D. For this first one, let's just label our ordered pair so we are all on the same page together. So I'm going to call -4 my x1 because it's my first x coordinate. This will be my first y coordinate. Then my second x coordinate and my second y coordinate. I'm going to jot this down quick so we can see it. Okay, then we're just going to plug in. So what is my x2?
5.
5. So I come down here, plug in 5 where I see an x2. What's my x1?
-4.
-4. What's my y2?
-1.
-1. Minus, what's my y1?
-6.
-6 squared. Does everyone see where I got those numbers?
Yep.
Okay. Now we're going to simplify a little bit here. What's 5 minus -4? Right, so it's really turned to pluses, so 9 squared. -1 minus -6.
5.
So that would be plus, right?
Yep.
So -1 plus 6 is 5. 9 squared? 81. 5 squared? 25. Add them together, what do we get?
6.
We're at 106. What's the square root of 106?
10.29.
Glenn? 10.29?
Yep.
So I'm going to go 10.3. Why don't you guys try the next one? See how far you get before you get stuck. Hopefully you don't get stuck. You guys like 16.4-ish?
Yeah.
Sweet. So that is the distance formula. What do you use that to find? Distance between 2 points, which would be the hypotenuse of your right triangle. Good deal. Okay, now we're going to move on to the midpoint of a segment. When you think of midpoint, what should you think? Middle, halfway, right? So it's the exact middle of a segment. That would be the midpoint. Midpoint is halfway between your two endpoints. And our formula for that, you're going to take your x coordinates, add them together, then divide it by 2. And same thing with your y. You're going to take your y coordinates, add them together, and divide them by 2. Yeah, first example is pretty straightforward. We're just finding the midpoint between S and T. So again, I'm going to label my points x1, y1, x2, y2. All right. What is my x1? -6. What's my x2? 1. Yep. So we're going to add those together. Divide by 2. What's my y1? 3. What's my y2? 0 all over 2. Then we just simplify. -6 plus 1? 5. -5 over 2. 3 plus 0 is just 3 over 2. If you're a fraction person, you can leave it like that. If you're a decimal person, you can leave it out. What kind of people are we? You guys fraction people or fraction? Me too. That works. So that's if we want to find the midpoint. But what if we're given the midpoint and we want to find one of the endpoints? Like this problem. It says find the coordinates of J if K is the midpoint of segment JL and L has the coordinates 3, -5. This is how I like to do the problem. I'll show you 2 different ways. I think it helps if you just draw a little segment. And I know it's segment JL, so I'm going to put J, L, and it tells me K is the middle, right? And then I'm going to label what we know. I know K is at -1, 2. And L is at 3, -5. And then we're looking for this guy, right? My other endpoint. So if K is the midpoint of this whole thing, what must be true between LK and KJ? Yeah, they have, like if this was 5, that would have to be 5, right? Okay, so here we go. How do I jump from 3 to -1? Subtract 4, right? So if I subtracted 4 this way, I gotta subtract another 4 to get to there. So what's -1 minus 4? -5. And same thing right here. How do I jump from -5 to 2?
7.
Plus 7, right?
Mm.
And You gotta add 7 more, so 2 plus 7 is 9. So if you're a more visual person, that way works, or you can use the formula. You should look at that way just to see what it looks like quick. Oops. Bless you. Okay, so that's my formula, but this time we know what our midpoint equals. So I'm going to write -1, 2. And I know that, where's L? We'll call this x1, y1. So I know my x1 is 3. Do we know the x coordinate of k? Not yet, so I'm just going to call it x all over 2. And then my y1 is -5 plus y, because I don't know what that is yet, divided by 2. Okay. What does this whole x coordinate have to equal? Right? That goes with this guy. So I'm going to have -1 equals 3 plus x over 2. How do I solve that?
Multiply by 2.
Yep. How do you undo division? You multiply, so times 2 times 2. So -2 equals 3 plus x. Then minus 3, so we get -5 equals x. Oh, what do we get up here? -5. So far, so good. This is too hard. I just wanted to show you because some people are more mathematical, and that's okay. And then I know this guy has to equal 2, so same process. Again, how do you undo divide by 2? Times, so we're going to get 4 equals -5 plus y. Add 5, y equals 9. Is that what we got?
Yeah.
Okay, so either way is valid. You do what works for you. I don't care. But I think the picture's easier. Personally. Okay, then one last little thing to talk about today. So we have this thing called a segment bisector. How many wheels does a bicycle have?
2.
How many wheels do bifocals have? Bifocal?
Glasses.
Yes.
Harry Potter.
Yeah.
Thank you, yeah. So the prefix bi means 2, right?
Yeah.
So if I'm bisecting something, I'm cutting it in half. Okay, so any segment, line, or plane that intersects a segment at its midpoint is a segment bisector. So it's like the knife that's cutting it in half. So if I am to look at this picture here, name the segment bisectors of segment PQ. So here's PQ. What is cutting that in half, that whole segment? Point M, right? But how do you know it's at the midpoint?
Is that the slashes?
Yeah, remember yesterday we said these slash marks mean that is equal to this, because those slash marks mean congruence. So good, M's 1. What else is 1? Yep. So we have point M. That's 1. Segment JM. Anything else?
Plane A.
Plane A, and I heard the other one. Tell me about KM. What is KM? It's a line. So there's a lot going on in that picture.
Did you say angle JMK?
You could if you really wanted to. Well, it's not. The only thing is it's not an angle. Just because this isn't a line. We'll talk about those next time. So good thought. Good thought.
I get smart.
Okay. 4 ends means every fourth problem, so you're only doing 12. What's 12 plus 4?
16,
20,
24, 28, 32, 36, 40, 45,